Hey, my name is Josiah Sampson. I am an assistant professor in the Department of Biology here at Elizabeth City State University.
Dr. Jeffrey Roush, Chair of the Biology Department, Elizabeth City State University.
Stem cell research is when scientists take embryonic stem cells from what is usually discarded embryos and use those because those cells still have the ability to differentiate into any different type of cell. So that one cell could differentiate into nerve cell, it could differentiate into a muscle cell, it could differentiate into a skin cell, it could be a bone cell. It still has the ability to turn into any type of cell necessary.
Best to my knowledge now, we've done that successfully with bladder cells. They can be converted from the stem cell or non-differentiated cell into a bladder cell pretty easily. So we understand the environment, the chemicals necessary for that. But yeah, any tissues in need of replacement.
Famous incident is going to be the case of Christopher Reeve. So this was the actor that played Superman in all the Superman movies. So he was thrown from a horse and had a neck injury, and of course the nerve cells that were in the spinal cord, excuse me, once nerve cells have matured, they don't grow anymore. So those damaged cells could not regenerate. So he was left paralyzed from the neck down. But by implanting embryonic stem cells into that area, you have the propensity, the likelihood to be able to regenerate healthy nerve tissue. So that injury could have possibly, if not completely, but been at least partially repaired. So there may have been some repair process there to help heal that injury. You have other types of injuries, any kind of nerve damage, injury that results from some mechanical or traumatic injury, car wreck, falling off a house or something, extreme like that. But also in terms of some genetic injuries, you can put healthy tissue in, and then maybe the healthy tissue can overshadow the genetically mutated tissue, so that you can grow healthy tissue to repair some genetic abnormalities.
What about Parkinson's disease?
Parkinson's disease would definitely fall into that area. Also stuff like cystic fibrosis. What else? There's some thought that Alzheimer's may respond toward embryonic treatment.
Okay.
Well, it would certainly be nice if, like you said, for example, if you had tissues that were damaged in an accident or degenerative nerve disease, and you needed a replacement of those tissues, and you could find a way to go back to these stem cells, which are undifferentiated. They haven't decided what they want to do in life, and through the right amount of chemical and environmental conditions cause them to grow into any other type of cell that's necessary. You can certainly look at replacing ones that are damaged in a human body with these that are grown outside of a human body.
Noted. You can cure some injuries, you can cure some diseases. You increase the longevity of the individual because of these diseased or damaged states that will increase the mortality of the individual, so you have a longer lifespan. At this point, there's no known risk to the recipient because there's not really too much known about any kind of allergic response that the recipient might have from the incoming cells.
Well, yeah, I mean, I think there's risk with any procedure. There's always a chance, of course, of rejection of tissues. I think an ideal situation would be not so much to look at stem cells, but to look at more of a cloning process of. Okay, yeah, we sort of addressed that. Certainly the two go hand in hand because they're not exclusive of each other. The same conditions that would be necessary to convert stem cell to differentiate into any cell that you would like is certainly going to require the same amount of chemical, the same type of chemical, the same external hormonal treatments, the same environmental conditions that would be necessary, whether you're talking about cloning cells that are already differentiated or to cause undifferentiated cells to move down a path that you would like them to proceed along.
Definitely. I was very pleased to see that one of the first things that this new president did was to repeal the limitations on stem cell research that had been imposed by the previous presidential administration. So this unties the hands of scientists to be able to do research on different diseases and to possibly find some cures that we would not have been able to find before.
Absolutely, and there's nothing holding us back from a scientific standpoint as far as making advances. Right now it's really a political and ethical decision that we're making. Initially, stem cells were only available from fetal tissue, and so you can imagine that's really a charged issue and a lot of emotional, a lot of emotions tied to that situation. But now we've realized that we can obtain stem cells from other sources that are not so emotionally charged, like umbilical cords and other tissues that would be routinely discarded without sacrificing any human life.
So research.
I'm completely for it.
All right. Thank you.
You're welcome.
Personally, I think if the cells are collected in a manner that isn't going to really cause people to start going down the path of selling fetuses and things of that nature, then I have no problem with it whatsoever. If I could change the subject a little bit, people have been complaining for many decades now about genetically modified organisms, putting genes into plants and having those plants go out into the wild, and those plants weren't supposed to do that. But we've really been manipulating agriculture and animal husbandry products for 20,000 years, because we've been selecting corn, for example, that had the largest ears, or we've been mating cows together that had traits artificially for thousands of years, and so we've now just find a way to kind of speed that process along. But given enough time, these classical breeding techniques, we would get at the same point whether we had inserted the genes in certain fashions or whether we had bred the traits in or out over many tens of thousands of years.
Right.
So we'll end up at the same place. It's just a matter of how quickly.
All right. Well, thank you, Dr. Ralph.
My pleasure. I thoroughly enjoyed it.
All right.